The algorithms behind your phone, the numbers in your bank, the stars on your map, all carry whispers from a time when Muslim scholars rewrote the future in the language of science. Welcome to Uncover Time, where today we travel through the world of early Islamic science, where the knowledge of Greece, India, Persia, and Babylon was reborn in Arabic and launched toward the modern world. The early caliphs understood something vital. The Arabs were behind in science, while the Greeks had left behind a treasure of knowledge in Syria, Egypt, and Mesopotamia. So the Umayyads left ancient Christian, Sabaean, and Persian schools untouched in cities like Alexandria, Haran, Jundashpur, and Antioch, places where Greek texts were still being copied in Syriac. Curious Muslim scholars began to learn Syriac and Greek, and what they found in those old texts amazed them. Works on medicine, math, astronomy, and philosophy unlike anything in the Arab world. Soon, translation became a national mission. Nestorian Christians and Jewish scholars turned Greek classics into Arabic, bringing Euclid, Galen, and Aristotle into the heart of Islam. Caliphs like Al-Mansur, Al-Mamun, and Al-Mutawakkil sent envoys across the Byzantine world, even to their Greek enemies, begging for manuscripts on medicine, mathematics, and astronomy. In 830 CE, Caliph Al-Mamun built a magnificent center in Baghdad called the House of Wisdom, Beit al-Hikmah, a place that would become one of the greatest scientific institutions in history. He spent over 200,000 dinars to fill it with books, tools, observatories, and translators, creating a dream team of scholars supported by the state. One of those translators was Hanan ibn Ishaq, a Nestorian Christian who translated over 100 works of Galen into Syriac and 39 into Arabic. He also brought into Arabic Plato's Republic, Aristotle's Physics, Hippocrates, aphorisms, and even the Old Testament from the Greek Septuagint. Al-Mamun rewarded him in gold equal to the weight of the books he translated, though another caliph later imprisoned him for refusing to mix poison, proving that science and politics were often dangerous companions. Hanan's son, Ishaq ibn Hunayn, followed in his footsteps, translating Aristotle's Metaphysics on the Soul, and ancient commentaries that shaped the direction of Islamic philosophy. By 850, nearly all major Greek scientific texts had Arabic versions, including the lost books of Apollonius, Hero, and Philo, which survive today thanks to Islam. Oddly, Muslims showed little interest in Greek poetry, drama, or history. In those arts, they looked to Persian traditions instead of Hellenistic ones. But in science and philosophy, they went all in, even if what they absorbed was mostly Neoplatonic, reshaped through centuries of mystical reinterpretation. The real Aristotle, untouched by later layers, reached the Islamic world only in fragments, mostly in his logic and scientific works, not his deeper metaphysics. Still, a powerful chain had formed. Knowledge flowed from Egypt and Babylon to Greece and Rome, then through Syria into Arabic, and finally to Europe and the Americas. One early witness to this flow was Severus Sebokht, a Syrian monk writing about astronomy in Hindu numerals as early as 662 CE, just after the Islamic conquests began. Hindu science played a major role in 773 CE under Caliph Al-Mansur. Indian works like the Siddhantas were translated into Arabic, carrying with them the decimal system and the zero by 813. The scholar Al-Khwarizmi was using Hindu numerals in his astronomical tables, and around 825 he wrote a book about them that would later give birth to the word algorithm. The Arabic word sifr, meaning empty, became zephyrim in Latin and was finally shortened into the word we all use today, zero. Al-Khwarizmi also gave us the word algebra from his book Algebra, where he solved quadratic equations using methods that spread to European universities centuries later. Another great thinker, Thabit ibn Qurra, worked in astronomy and medicine, but also became famous for geometry, expanding ancient Greek ideas with his own. Abu Abdallah al-Battani, also known in Europe as Albatagnius, took trigonometry far beyond where Hipparchus and Ptolemy had left it, shaping the very formulas we use today. Under Caliph al-Ma'mun, astronomers were tasked with confirming or correcting Ptolemy's data, and they even studied sunspots long before Europe rediscovered them. These scholars measured the distance of 1 degree of latitude using the sun's angle from Palmyra and Sinjar. Their result of 563 miles was only half a mile off from what we know today. Abul Farghani, writing around 8T, created a book on astronomy that would be trusted in Europe and Asia for 7 centuries. Al-Battani's observations, done over 41 years, were so precise that he estimated the precession of the equinoxes at 54.5 arcseconds per year, nearly matching today's value. One scientist, Abul Wafa, may have discovered the third lunar variation 600 years before Tycho Brahe, showing that Islamic astronomy reached far beyond theory. The instruments they used were massive and beautiful. Armillary spheres, giant quadrants, and sextants, up to 80 feet across, all crafted with artistic care. The astrolabe, perfected by Muslim hands, was brought to Europe and became essential to navigation. Until the 1600s, both a tool of science and a symbol of art, while they mapped the heavens, they also charted the earth, because the Islamic world thrived through travel, trade, and connection. Suleiman the Merchant went to China around 840 CE, and his journey was recorded over 4 centuries before Marco Polo. Other geographers described India, Ceylon, the East Indies, and Africa with incredible detail, often based on first-hand observation, not rumors. By 985, Al-Muqaddasi had traveled nearly the entire Islamic world, creating a detailed account of cities, cultures, and landscapes that shaped the age. But it was Al-Biruni, born in 973, who became one of the greatest scientists the world has ever known. Combining philosophy, physics, and geography with rare brilliance, he served under kings in Khwarizm, and later under the famous conqueror Mahmud of Ghazni, who brought him to India to study its people, beliefs, and sciences. There, Al-Biruni learned Sanskrit, translated Indian texts, and compared Hindu, Greek, and Islamic ideas, praising the Greeks, but admiring India's depth. He even translated Euclid into Sanskrit and Indian astronomy into Arabic, building bridges between civilizations. Al-Biruni knew the Earth was round, guessed the idea of gravity, and proposed that the Earth might spin on its axis. 1,000 years before it was confirmed, he described how springs and wells work using hydrostatic pressure, measured specific gravity of 18 minerals, and guessed the Indus Valley was once a sea. He studied astrology, chemistry, mathematics, and history, and left behind detailed books on almost every science known in his time. Al-Biruni's method was modern. He rejected blind belief, demanded observation, and insisted on honesty. Writing that tradition, pride and politics must never block truth. In the same age lived Jabir ibn Hayyan, the father of chemistry, experimenting with powders, acids, and distillation while chasing the philosopher's stone. Though many works attributed to him were later creations, the real Jabir changed the world by introducing precise experiments, formulas, and the alembic, a tool still used in chemistry. Muslim chemists made huge strides discovering acids and alkalis and cataloging hundreds of medical substances. Laying the foundation for pharmacy, even biology showed sparks. Muslim botanists crossbred plants, described dozens of species, and believed in an evolutionary ladder from minerals to man. Today, in labs across the world, the legacy of those early Muslim scientists lives on. In algorithms that run our computers, in zero-based code that powers the internet, and in medical tools that still echo their designs. The spirit of Al-Khwarizmi and Al-Biruni now lives in space telescopes. Artificial intelligence, biomedical engineering, and the global language of mathematics. From the house of wisdom to the digital world, the chain of knowledge has never broken, only grown stronger, as humanity reaches not just for the stars, but for understanding. These scholars did not only write books, they healed the sick, mapped the stars, saved Greek knowledge from vanishing, invented tools of calculation, and taught the world to ask questions before believing. They proved that knowledge belongs to everyone, and that science, when guided by wisdom and humility, is one of the greatest gifts we can offer to each other. Thank you for watching Uncover Time. Like, share, and subscribe for more journeys through history.